Welcome back to the MCP Fundamental series, and this is episode 3. In the last episode, we cracked open the architecture, host, client, server, and we briefly mentioned that every MCP server exposes three things: tools, resources, and prompts. We didn't go deep though, we just named them. Today, we go deep, and I want to start with a confession. When I first learned MCP, I genuinely could not tell the difference between a tool and a resource. They both felt like the AI gets access to something. It took me building a few servers to actually internalize when to use which. So that's exactly what this episode fixes. By the end, you'll know precisely what a tool is versus a resource versus a prompt. You'll see real TypeScript code for each one. And most importantly, you'll know exactly which one to reach for when you're building your own MCP server. Let's get into it. Quick 30-second recap before we dive in. Last episode, we established that the MCP server is the third layer in the architecture. It's where capabilities actually live. And we said every server exposes three types of things to the client: tools, resources, and prompts. Look at the diagram. The server in the middle, fanning out into three categories. We know the names now, we know they exist. But here's what we didn't cover. What do each of these actually do? What does the code look like when you're defining a tool versus a resource? And critically, when you're building your own server, how do you decide which primitive to reach for? Those three questions are exactly what today's episode answers. Let's start with a side by side look at all three, then we'll go deep on each one individually. Here's the fastest way to tell these three apart. And I wish someone had shown me this exact slide when I started. Tools are actions the AI takes. The closest analogy is a function call. You give the model a function with a name and some parameters, and the model decides when to call it. Critically, tools are model controlled. The AI itself decides if and when to invoke a tool based on the conversation. Resources are data the AI reads. Think of it like a GET request. You're exposing a piece of data at an address, and something can fetch it. Resources are app controlled, meaning the host application typically decides which resources to attach to the context, not the model autonomously. Prompts are templates for workflows. Think of them like a saved macro, a pre-built structure that triggers a specific multi-step interaction. Prompts are user-controlled. The human explicitly invokes them, usually through a slash command or menu in the host application. That control dimension is actually the single most useful way to remember the difference. Model decides that's a tool. App decides that's a resource. User decides that's a prompt. Keep that distinction in your head as we go deeper into each one. Let's start with tools, since they're the most commonly used primitive and the one you'll reach for most often. Every tool has three essential parts, and you can see them laid out on the left. First, the name, a unique identifier for the tool, something like create underscore issue or query underscore database. This is what the model references internally. Second, the description. This might be the single most important field in the entire tool definition, because the model reads this description to decide when to call the tool. If your description is vague, the model won't know when it's appropriate to use it. If it's precise, the model will call it at exactly the right moment. Third, the input schema. This defines what arguments the tool accepts, and it's typically defined with ZOD in TypeScript, giving you full type safety and automatic validation. Now look at the code on the right. This is a real TypeScript example using the MCP SDK. We're calling register tool with the name create underscore issue, a title and description for the model to understand its purpose, an input schema using ZOD to define a title and body string, and then the actual handler function, the code that runs when the model decides to call this tool. That handler is where your real logic lives. In this case, calling out to the GitHub API to actually create the issue. This is the complete anatomy of a tool: name, description, schema, handler. Let's trace through a real tool call end to end, because seeing it in motion makes everything click. Step 1. The user types something natural. Open an issue about the login bug. Nothing technical, just a plain request. Step 2. This is the important part. The model The LLM itself looks at the conversation and looks at the list of available tools. It recognizes that create underscore issue matches the intent of this request far better than anything else. This decision happens entirely inside the model. Nobody explicitly told it to call this tool. It inferred that from the description we wrote. Step 3. The model generates a tool call. The client sends a tools/call JSON RPC request to the server with the structured arguments, a title and a body, both extracted from the natural language request. Step 4. The server actually executes the handler function, calls the GitHub API, creates a real issue, and returns a result. Look at the JSON response at the bottom. This is the actual shape of a tool result in MCP. A content array with the response text and an is-error flag so the model knows whether the call succeeded or failed. This loop, natural language in, structured action out, is the entire value proposition of tools. The user never had to know the function signature. The model bridged that gap. Now let's go deep on resources, the second primitive and the one most often confused with tools. A resource is fundamentally a piece of data exposed at an address, a URI. The key conceptual difference from a tool: the model doesn't decide to call a resource the way it calls a function. Instead, the host application is typically the one deciding which resources get attached to the conversation context. Maybe the user picked a file from a drop-down, or the host automatically attaches the currently open file in an editor. Look at the URI schemes on the left. File : / for local files, like readme.md, db : / for database-backed resources, like a schema definition. And you can even define totally custom schemes for your own application's data model, like custom : / tickets /482 for a specific support ticket. Now look at the code. We call register resource with a name, readme, the actual URI file : / readme.md, some metadata like title and MIME type, and then a handler function that runs when this resource is requested. The handler reads the file from disk and returns its contents wrapped in a structured response with the URI and the text. The shape of a resource is simpler than a tool. There's no complex input schema to validate because you're not calling it with arguments. You're just fetching what's at that address. Think of resources as your MCP server's read-only API surface, the things an AI application can pull into context without taking any action in the world. Resources come in two flavors, and the distinction matters a lot once you start building real servers. Static resources have a fixed URI you know ahead of time. File : / readme.md always points to the same file. These are great for configuration files, documentation, or any fixed dataset that doesn't change per request. Dynamic resources use a URI template, a pattern with placeholders that get filled in at runtime. Look at the example. Tickets : / ticket ID. This single registration can serve an infinite number of actual resources. Ticket 482, ticket 901, whatever ID gets requested. This is exactly how you'd expose per record data, individual users, individual orders, individual support tickets, without registering a separate resource for every single record in your database. Look at the code at the bottom. We use a resource template instead of a plain string URI. The template tickets : / ID captures the ID parameter automatically, and our handler function receives that ID and uses it to query the database for that specific ticket. This pattern, one template, many addressable resources, is what makes resources scale to real production data. You're not hand registering every record, you're defining the shape of the address space once. Prompts are the third primitive, and they're the most underused, which is a shame because they solve a real problem. A prompt is a pre-built template for a specific workflow that the user explicitly invokes, often through a / command in the host application. Unlike tools, the model doesn't decide to use a prompt on its own. Unlike resources, the host doesn't silently attach it either. A human consciously picks it. Why do prompts exist? 3 reasons. First, they standardize common multi-step workflows. Instead of every user typing out a long, carefully worded request for a code review, the server author can define the ideal prompt structure once. Second, this means the server author, the expert who built the integration, gets to encode best practices into the prompt rather than relying on every user to write good prompts themselves. Third, prompts accept arguments, so they're customizable templates, not just static text. Look at the code. We register a prompt called code_review with an args schema requiring a diff string. The handler function takes that diff and returns a properly structured message array. In this case, a single user message containing the text review, followed by the actual diff. When a user in Claude Desktop types something like /code_review and pastes a diff, this is the exact code that builds the resulting prompt that gets sent to the model. Let's see prompts in action with the most common real-world pattern, the /command menu. Look at the mockup on the left. This is what it feels like inside Claude Desktop or any MCP-compatible host. The user starts typing a / and a menu pops up showing every prompt that connected MCP servers have registered. Code_review, bug_report, release_notes. These are all prompts exposed by different servers, surfaced in one unified menu. The user explicitly picks one, say code_review, and the host will prompt them to fill in any required arguments, like the actual code diff to review. Now look at the sequence on the right for what happens after the user makes that selection. Step 1. The host sends a prompt/get request to the server with the diff argument filled in. Step 2. The server runs the handler we saw in the previous slide. It takes that diff and builds out the full message array using the template logic. Step 3. The host takes that returned message and injects it into the conversation as if the user had typed it themselves, but now it's perfectly structured, using the exact wording the server author intended. Step 4. The model receives this well-crafted prompt and responds with a proper, structured code review. This is the power of prompts, turning "I'm not sure how to ask for a good code review" into a single, polished /command. Let's bring it all together in one comparison table. This is the slide to screenshot and keep handy. Look at controlled by. This is the single most important row. Tools are controlled by the model. The AI decides when to call them. Resources are controlled by the application. The host decides what to attach to context. Prompts are controlled by the user. A human explicitly picks them. Purpose. Tools take action. Resources read data. Prompts run a workflow. Analogy. If you're a developer, think of tools as function calls, resources as get requests, and prompts as saved macros or templates. Has side effects. Tools often do because they're taking real action in the world, like creating a GitHub issue or sending a message. Resources and prompts are read only by design. They don't change anything, they just supply data or structure. And triggered via. Tools get triggered by model decision during a conversation. Resources get triggered by auto-attachment from the host or a user manually picking a file. Prompts get triggered explicitly via a /command. If you remember nothing else from this episode, remember this table. When you're designing your own MCP server and you're not sure which primitive to use, ask yourself, who should be making this decision? The model, the app, or the user? That answers the question. Let's zoom out and see how all three primitives come together in one real production-style MCP server. Picture a GitHub MCP server, a single codebase, a single deployed service. It exposes all three primitive types simultaneously, and each one is used for exactly the job it's best suited for. For tools, it exposes things like create_issue, merge_PR, and create_branch. These are all actions, things that change state in the real world. The model decides when to call these based on the conversation. For resources, it exposes things like file://read.md for reading the repository's documentation, and a templated resource like repo/issues/id for reading any specific issue by its ID. These are read-only, pulling data into context without taking action. For prompts, it exposes /commands like code review and release notes, standardized workflows that a human explicitly triggers when they want a specific, well-structured interaction. This is the realistic picture of what a mature MCP server looks like. It's not just tools or just resources. It's a thoughtful combination of all three, each chosen deliberately based on who should be making that decision: the model, the application, or the user. That's the mental model I want you to walk away with today. And that's a wrap. Here's what you should walk away with: tools are model controlled actions. The closest analogy is a function call. The AI decides when to invoke them, and they often have side effects like creating an issue or sending a message. Resources are application controlled data. The closest analogy is a GET request. They're read only, addressed by a URI, and the host typically decides what gets attached to the conversation. Prompts are user controlled templates. The closest analogy is a saved macro. A human explicitly picks them, usually through a slash command, and they encode the server author's best practices into a reusable structure. And real mature MCP servers combine all three deliberately, using each primitive for exactly the job it's good at, based on who should be making that decision. Thanks for watching, and I'll see you in the next one.